Hello friends, welcome to Tech World Affairs. Has the thought ever crossed your mind, how does air conditioning work? Or how do engineers design systems to control humidity in large buildings? The answer lies in understanding the properties of air, and more specifically, a tool called the psychrometric chart. Dive into the world of engineering thermodynamics, where the psychrometric chart reigns supreme. This chart is not just a bunch of lines and numbers. It is a graphical representation of the physical and thermal properties of moist air. Firstly, let's talk about air. Air is a mixture of different gases, predominantly nitrogen and oxygen. But it also contains water vapor, and it's the amount of this water vapor that plays a significant role in how we perceive comfort in our environment. Now, imagine the chart. Picture a two-dimensional graph where each point represents a specific condition of moist air. The horizontal axis measures the dry bulb temperature, the air temperature measured by a thermometer freely exposed to the air but shielded from radiation and moisture. The vertical axis, on the other hand, measures the amount of moisture in the air or humidity. Between these two axes, a series of lines represent other critical properties. The curved line on the far right is the saturation curve, which shows the maximum amount of moisture air can hold at a given temperature. Any point to the right of this line represents supersaturated air, a condition that usually leads to the formation of dew or frost. Other lines on the chart represent the wet bulb temperature and dew point temperature. The wet bulb temperature is the lowest temperature that can be achieved through evaporative cooling, while the dew point temperature is the temperature at which air becomes saturated when cooled without adding or removing moisture. Now, how does one use this chart? Engineers and scientists use the psychrometric chart to analyze air conditioning systems to predict how changes in temperature, pressure, and humidity affect human comfort, and even to forecast weather. To use the chart, you start with two known properties of the air, such as the dry bulb temperature and relative humidity. Find these values on the respective axes, and where they intersect on the chart, that's your air's condition. From that point, you can read other properties like dew point temperature or specific volume. The psychrometric chart is a powerful tool that allows us to visualize the complex interrelationships between the different properties of air. It's a testament to the sophistication of engineering thermodynamics and how it helps us understand and control our environment. Before we wrap up, remember that the psychrometric chart is not just for engineers. Anyone interested in understanding how changes in air properties can affect us and our environment can learn to use it. So next time you're adjusting the temperature on your air conditioner, you'll have a deeper understanding of the science behind it. Thank you for tuning in to Tech World Affairs. Please subscribe for the latest updates and join us next time as we continue to unravel the fascinating world of technology and engineering.